Okay, in this video I'm looking at the General Maths 2022 external paper, the multiple choice section. So for question 1, we have an activity, a project network given to us, and we're wanting to look at the non-critical activity for this project network and what the float time is. So when we're working out those float times, we're working backwards. So here we've got like our 38 take 5 is 33. Our 33 take 17 gives us 16. If we go this way, the 33 take 10 gives us 23. So that's telling us the latest time that you can start watching the news to not impact on the total time for the network. So that means we've got our 23 here, and the difference between 3 and 23 is 20 minutes of float time there. So our answer is B. Then we've got our picture here of a network, a graph, and we want the total number of vertices. Now vertices are our dots that we have here. So we've got 1, 2, 3, 4, 5, 6. So our answer is C, 6. Question 3 asks us about a table and the equivalent graph for that. So we've got the minimum and maximum temperatures on January the 1st each year in Bundaberg. Which time series plot best represents the mean temperatures? So mean, where we would do the minimum plus the maximum divided by 2. Now we can rule out some straight away. So we can see this one down here, D. That's not going to be the answer because we've only got 3 points plotted. So what they probably have done is found like the 3 mean average for those points, and that's what they've plotted there. Then we can have a look at the remaining 3 that we need to choose from. Here we've got the plots of 31.8. Here we've got 29.5-ish. Here we've got 32 point something. So it looks like they're plotting the maximums. So that's out. Over here we've got or down here, sorry, we've got like about 22 and a bit. We've got about 17.5-ish. Here we've got about 24, etc. So it looks like they're plotting the minimums. So that's out. So my answer is A. Now I could have gone through and worked out all the averages as well just to double check that, but I could rule out a few anyway and get to my answer. Question 4, we've got again a situation where need to pick the correct graph for it. So we're told that they've got a recursive function where we've got t of n plus 1 is tn plus 2, so it's going to go up 2 each time. We've got the number of laps they swim is what we're working out, and the number of weeks is along the bottom. So we know straight away that these ones aren't going to be correct because they've got number of laps per week along the bottom. So we can rule them out. Then we look over here and we're told T1 equals 4. So here we've got 1, 4. Here we've got 1, 6. So we know it can't be that one. So our D must be the answer. For question 5, we have been given a table with our months, and it has the books sold per month by an online bookstore. If the simple 3-point moving average in October is 54, what is the simple 3-point moving average in May? So it's quite nice they've actually given us the answer for October just in case we weren't sure what to do. So for the October one, we would be doing 40 plus 45 plus 77 divided by 3. So that's what we need to do for our May. We're going to look at either side of May. So 65 plus 89 plus 65 dividing by 3. And our answer is going to be 73 there. So the answer is B. Then we've got question 6 is our semi-Eulerian graph. We've got here can be changed to an Eulerian graph by doing something. So for our Eulerian, we want all even orders for our vertices. So here we all even. Here we've got 1, 2. That's only got 1. C has got 2. B has got 2. So we're wanting to see if we add a loop to vertex B, that changes that to even. Well, it already was even, but it doesn't help with our ones that were odd. So the ones that we've got that are odd are our this joining between. Sorry, just so I was going to say mine is going to be the adding an edge between A and D. So I'll draw that in there. So I now have even. The loop gives me the even there and even there, so it changes it to the Eulerian type 1 by adding that edge between A and D, because we want to be able to get, so the main thing is we want to be able to get, we need the even and we need to be able to get to all of the points there. So we want it connected, which is why we needed the extra connection there as well. Then we've got our question 7. So they've given us the final matrix for the Hungarian algorithm, so it saves the time of doing that there. So we just need to do our bipartite graph to then come up with the optimum allocation. So we've got E, F, G, and we've got the L, M, V there. And so E can go to L or M, our F can just go to L, and our G can only, it can go to M or V. So because our F can only go to L, that has to be the answer there, F to L. E then has to go to M, and then that means G must go to V. So C is our answer there. That gives us that. Question 8, having a look at question 8. We've got a scatter plot, and we're asked that for 2018 the annual number of visitors could be either interpolated, extrapolated, and some numbers there. So for 2018, it's within values that we have graphed, so we know it's going to be interpolated, because extrapolated would be either side of our minimum or maximum, looking at outside the data range. So we know it's got to be an interpolated, and then we just have to go, okay, well, what makes the most sense here? So if we go 2.7, that puts that at about there. Whereas if we do the 3.2, that brings it up here. So the 2.7 fits the data more appropriately. So then A will be our answer. For question 9, we want to see which one is a spanning tree. Now, a spanning tree means that each vertex is only connected once, and we often talk about the minimum spanning tree, like the shortest amount it would take to join them all up. So they don't have to be joined to each other, but each one has to be connected in some way to the tree. So A we can rule out because R is not connected there. And we don't have any loops in the minimum in a spanning tree either, so that one's out. And here we've got multiple connections to P and to Q and to R, so that can go because we don't need that. So B is our spanning tree there. Question 10 states an explanatory variable followed by a response variable. So car manufacturers and car colours, not ringing any bells as obvious things that you would be investigating. Dog breeds and frequency of names, again not sure. The two that make more sense are like plant growth and amount of fertilizer used. That kind of sounds like something that you might measure. Daily temperatures and daily ice cream sales. Now we're not going to use C because the plant growth would be what you'd measure based on the amount of fertilizer, like as in if you use more fertilizer, will it grow more? So that's going the wrong way round because we want explanatory and then response, so it's out. So the daily temperatures and the ice cream sales is an example that would state that explanatory variable followed by response. Response is generally a numerical value, so that's why the A and B don't kind of fit to that criteria. Question 11, we're given an equation for our free throws in basketball, T being the number of hours in training, and so T is the number of free throws and the H is the hours of training, and we've got the predicted number of free throws for a 5-hour training session rounded to the nearest whole number. So we're subbing into that equation. We're going to put a 5 in there, and when we do that, I'll grab my calculator. we have got the 12.974. We are multiplying that by the 5, and then we're adding that to the 26.781. So we get 91.651, but we've been asked to round to the nearest whole number, so that means we're rounding it to 92, which is D. Question 12 is a nice one, identifying the one that best demonstrates a strong negative. So A is positive, it's out. B doesn't look like there's anything going on there. D is another positive one, so our answer is C. So we can see that it's trending down as opposed to A and D that are trending up, and B that doesn't seem to have any trend to it. Sorry for that, had a phone drop there. Question 13. The two-way table summarises the semester 1 results, and we've got machinery and electrical, and they either satisfactory or unsatisfactory. The 10% cell, so we're looking at this one, what does that indicate? So the 10%, we're looking at where the hundreds add up to. So see how we've got 80 and 10 here, that adds to 90. So we're not going across. So we're looking at the 100% here and 100% here. So out of the students that got a satisfactory for machinery, 80% got satisfactory for electrical and 20% got unsatisfactory. Out of the students who got unsatisfactory machinery, 10% got satisfactory electrical and 90% got unsatisfactory. So the 10% of all students, we know it's not going to be that because it's the 10% of the unsatisfactory machinery ones. Then it's got 10% of all students achieved unsatisfactory machinery. No, again, it's not of the all students. So then we get down to here with C and D. 10% of the students who achieved satisfactory in electrical achieved unsatisfactory in machinery. So that's not what we're looking at. We're looking at the unsatisfactory in machinery. So that's our answer D. 10% of the students who achieved unsatisfactory in machinery achieved satisfactory in electrical. Question 14, we've got a time zone one. A rugby fan in Perth plans to watch a live match in New Zealand next winter. So winter is the key info there. The time zone for Perth is +8, UTC +8, and for New Zealand is UTC +13 in winter. So we're comparing the UTC +8, UTC plus winter. So for the time in New Zealand, we're adding 3 from the Perth time. So if it's 6:30 in New Zealand, going back the other way, we would be taking away 5, which gives us the answer A, which is 1:30. And the last one that we're looking at here, we've got the actual distance between two cities has been correctly calculated as 556 kilometres. Now, we have the two options with doing the distances, the 111.2 times the angular difference. That's if it's on a prime meridian, on a line going from north-south. Or if it's on a parallel of latitude, then it would be the 111.2 because of the angle that it's on, and then you will be multiplying that by the angular difference. Now, when I get that 556, I did 556 divided by 111.2, and I can see I get a 5. So I'm guessing it's going to be on one of those lines that are going from top to bottom. So I'm looking for ones that have a matching east or west numbers. So I've got 104 and 104 west. I've got 104, 104 west, that works. 150, 150, 145, 150. So that one's out. We can automatically get out the D. Then if I've got a 5 when I divide by 1.2, my angular difference is going to be 5 degrees. So I want to look at then these two numbers and look which ones have a difference of 5 degrees. So if I'm north and south, that means I'd add them. So 2 plus 3 is 5. Here I've got north, so I would be subtracting. 3 take 2 is 1. Here I've got north-south, I'd be adding, which is 25 plus 30 is 55. So my answer is A.